Hi everyone, and welcome to lesson 4 of Unit 5. And so we're going to be working more with these transformations of parabolas today. And in particular, we're going to work on this idea of stretching and reflecting parabolas, okay, and what the equations would look like. So this is kind of part 1 of transformations. Okay, so one thing I want you to keep in mind as we go through this lesson and in future lessons is this: we've got to keep the idea of the standard, or what I call the bread and butter parabola, in mind, and that's y equals x squared. And I'd like you to be able to think about this standard parabola. I'd like you to think about its graph and its table of values. So let's try this out. Let's graph this standard parabola. So if we pick various values of x, and I've gone from -3 to +3, if we input -3 into the equation, so it would be y is equal to -3 squared. Well, -3 times -3, that's a +9. Okay, so -3 is 9. If we put -2 in there, so y is equal to -2 squared. Well, again, a negative times a negative is a positive. You get 4. Y is equal to -1 squared, so that's 1. Y is equal to 0 squared, which is just 0. And then if we start putting these positive numbers in, 1 squared, well, that's just 1. And 2 squared is 4, and 3 squared is 9. Okay, so those are the points on our bread and butter. Let's graph those points. So look at this. If I started at -3, I'd put a value there at 9. At -2, it's at 4. At -1, it's at 1, 0, 0. 1, 1, 2, 4, 3, 9. Okay, so those are the points. And then if we were to graph that, bear with me, I'm going to do this freehand. Okay, something like that. Let me try it one more time. Let's see if we get a little bit closer. Sure. Okay, and the points just keep going on and on. So that's the bread and butter parabola. That's y is equal to x squared. Okay, but now we're going to start. We know that quadratics can be anything. You know, they can be, we've seen quadratics, you know, things like this. Y is equal to, I don't know, 7x squared plus 2x plus 3. We've seen them in factored form. They look like this: x plus 2, x minus 3, and so on. So, you know, obviously the bread and butter one is just one of an infinite number of parabolas. So we're interested in what all these other numbers, and in this case here, if I expand this one, it's x squared plus 2x minus 3x, so minus x minus 6. Like, what do all those numbers do to the parabola? Well, let's focus in on one letter. And what we'd like to do today is focus in on the value that's in front of the x squared. And we've called it a before, and so we'll stick with that. Like you saw it when we did the quadratic equation. It was ax squared plus bx plus c. So anyway, we're working on the a. What does the a do to a quadratic? All right, that's the goal. All right, well, first of all, oh, sorry, I'm going to go back and do one thing here. I'm going to tell you what it does. I'm going to tell you what it does. So the a does two things, or has the potential to do two things. Can do two things. So number one is the sign determines the direction of opening, the direction of opening. So we're going to quickly look and see, well, what's the sign of A? And then the second thing A does is its value, its value determines the shape of the parabola. And basically by shape what we mean is is the parabola stretched? Is it all stretched and really a thin parabola? Or is it compressed? And is it a wide parabola? Okay, so the value that A takes on. So in other words, if this was our bread and butter parabola, you know, just kind of draw it like that, then if we're going to see that the A, if it's a very large number, can stretch it, and so it would be something like this. It'd be a very thin parabola, and we call that stretching it. Or here, it can be compressed. And what we mean by that is you can imagine that it's this wide parabola, nice and wide. So the value determines the whether it's stretched or compressed, and the sign determines whether it is opening up or whether it's opening down. So is it flipped underneath? All right, well, here we go. Let's focus in on the two of these. So part one is the sign. So is it positive or negative? And here's what we need to know, is that if A is positive, the parabola opens up. The parabola opens up. And we kind of knew that. We'd studied that in Unit 4. And if A is negative, the parabola opens down. It's been flipped over, opens down. And so we call that a reflection. A reflection over the x-axis. Okay, it's a reflection over the x-axis. All right, well, let's take a look at this. So here we go. I'm going to put my points on here again, and I'm not going to go through the whole process of getting them. I'll just write them in here. If you want to look, you can look at our first slide and you can see that these are the values of our bread and butter. And so I'm going to put those ones on there, 1 and 1, 2 and 4, -2 and 4, and 3 and 9, -3 and 9. Okay, so there it is. That's what we call the bread and butter. Well, look at this, that if it was -x², then technically this 9 becomes -9 because you take the negative of what you got in when you sub the -3 in there. So it becomes -9, becomes -4, -1, negative of 0 is still 0, and then -1, -4, and -9. After you've plugged the value in, squared it, you then have to apply the negative to it. And so that's why it ends up looking like this. So here the values are -2, -4, 2, -4, and then 3, -9. So this is what it looks like. So this one is y is equal to -x². It's been flipped. and this one is y is equal to x squared. Okay, so basically you look at the sign, and the sign is going to tell you whether it's a reflection over the x-axis. Okay, part 2, we're going to look at the value. And basically the value of A changes the shape. So for the next little bit, I want you to, let's ignore the sign. Because we know what the sign does. We know that the sign, if it's positive, it's up. If it's negative, it's flipped over the x-axis. So let's ignore the sign for just a minute. And so look at this. If A is equal to 1, which to be honest is just the bread and butter one, there's no change. There's no change to the original function. Yeah, so if it's 1, it's just y equals x squared. Okay, if A is greater than 1, okay, so remember we're ignoring the sign, so it could be 3, it could be -2, because, you know, again, you're going to say, well, wait a second, -2, Mr. Webster, isn't greater than 1, but remember, we're focusing in just on the value, not on the sign. So it could be any of those values, so i.e., if it was, if A was equal to 3, if A was equal to -2, etc., any of those values, okay? So any value where the absolute value of A, just the number, if the number is greater than 1, we call that a vertical stretch. And basically, the parabola becomes thinner compared to the original bread and butter one. Okay, so think of it as thinner or skinny. Okay, now if A is less than 1 and greater than 0, so if it's basically if A is a fraction, so i.e. if A was equal to, I don't know, 1/2, or A was equal to -0.333, so -1/3. Remember, we're focusing in on the value here, not the positive or negative. So if it's a fraction, we're going to call that a vertical compression. It's a vertical compression. And essentially, the parabola is going to get wider. It's going to get wider, or you know, kind of flattened out. Okay, so in this case, look for a fraction between 0 and 1. All right, because remember, there are other fractions, like if it was 3/2, technically that's 1.5, but that would fall into the category of A being greater than 1. So we're looking for fractions between 0 and 1. Okay, well, let's try one of these. And so sure enough, let's start by putting down our bread and butter numbers. So 9, 4, 1, 0, 1, 4, and 9. Okay, let's graph it. It's always nice to have that bread and butter one there as a comparison. Okay, and okay. Okay, so there it is. That's y equals, here, I better not write it there just in case I run out of room. That's y is equal to x squared. Okay, well, let's do y equals 3x squared. So in this case, A is equal to 3. Okay, well, essentially, what we're going to do here is that it's going to be 3 times the value there, because watch this, y is equal to 3 times, we're still go back to this -3, negative 3 squared. Well, that's equal, negative 3, you got to do the exponent first, so negative 3 squared is 9, 3 times 9 is 27. So basically, having the 3 there is just doing this value times 3. I take this, and that's why I'm going to multiply it by 3. Okay, so for this one, it's going to be this value times 3, so it's 12. Here, it's 3. Here, it's still 0. Here, it's 3. Here, it's 12. And here, it's 27. So by applying this 3x squared, let's see where this goes. Now I noticed that I made a little error here. I should have labeled that one on the outside. I'm going to just fix this. Okay. So here we go. I'm just going to label this on the outside. That's y is equal to x squared. Well, now let's start graphing the other one. Well, so 0, 0 is a point, but look at negative 1, it's 3, and at 1, it's 3. At 2, it's all the way up here at 12. Now, I don't have 12 on there. I'll guess at it. And at negative 2, it's 12. So look at this parabola. It's nice and thin. So that one is y is equal to 3x squared. Okay. Now we didn't do a fractional one here. Maybe I'll add a fractional one in just so that you guys can see it. How about if it was, I'm going to do another one here. Let me change color. I'll just, I'm going to move this over. I'm just going to put it right in here. Okay. So that one was 27. Oh, okay. So here, how about if we did y is equal to 1/2 x squared? Okay, so what would that do? Well, it's going to be half of whatever this value is. So half of 9 is 4.5. Half of 4 is 2. Half of 1 is 0.5. Half of 0 is still 0. Okay. Half of 3, half of 1 is 0.5. Half of 4 is 2. And 4.5. Okay, so let's graph that one. So here we go. If it was at negative 3, it would be at 4.5, so it's right there. If it was at negative, oh, I think I went to the wrong one there. Let me fix that up. Here it is, negative 3, it would be negative 4.5. If it was negative 2, it would be 2. If it was negative 1, it would be 1/2. 0, 1, it's 1/2. 2, it's 2. And 3, it's 4.5. So look at this one. This one you're going to be able to see is going to be wider. Okay, so there we are. We're the different values of A, and you can see that the green one is a stretch of it, of the original bread and butter one. It's a stretch up, and whereas the purple one is a flattening. It's a flattening or a wider. Okay. What about if we combine them? And so here I wanted to show you this one. Oh, this is where I did the y equals 1/2. But let's do, so this one obviously has a negative sign, so we know it's going to be flipped. And it's got a 1/2 as its a value, so I know it's going to be compressed. But let's try this out. So watch this. Let's just build it up gradually. And it's nice to see this gradual change. So for the original bread and butter, our values are 9, 4, 1, 0, 1, 4, and 9. If we implement the a of 1/2, it changes this to 4.5, because we're doing 1/2 of those values, 0.5, 0, a 0.5, 2, and 4.5. And then finally, if we implement the negative 1/2, it becomes negative 4.5. Notice how we're just modifying those values. Negative 2, negative 0.5, 0, negative 0.5, negative 2, and negative 4.5. So that's kind of the process of implementing the different A's. Okay, so here we go. Let's do the original bread and butter one. So 1, 1, negative 2, and 2 are at 4. 3 is at 9, and negative 3 is at 9. So there we go. So there's the bread and butter. Okay. If we implement the 1/2, that's the 1/2 is this one. So that would be 0, 0. It would be at negative 1, negative 0.5. A negative 2, it would be at, I haven't flipped it yet. 2, and negative 3, it's at 4.5. Okay, so I'll just bring those ones in. So look at this. So this one it's going to be wider. Okay, but then finally, if we do the one that they've asked us, which is the flip, it's going to look like this. At negative 3, it'll be negative 4.5, so it's going to be right about there. At negative 2, it's at negative 2. At negative 1, it's at negative 0.5, 0, 0, and then we just have the reflected points. Okay, so here it is. There's your final parabola. That's y is equal to negative 1/2 x squared. So it just shows you how we can transform these parabolas from the original parabola to the final one. One last example here is in one of your homework questions, they ask you to do it without graphing. They say just describe in words the transformations to the standard parabola to get the new parabola listed. So let me just help you with that. So if I gave you y is equal to 7x squared, you could basically say you would vertically stretch the original parabola by a factor of 7. So you'd take all your original y values and multiply them by 7 to get the new one. Okay, let's try another one here. What if it was negative 5x squared? Well, it's vertically stretched. It's vertically stretched by a factor of 5. So you made it nice and thin by a factor of 5. Okay, and because of the negative sign, and it's reflected over the x-axis. Okay, so it's been stretched up and then reflected. And then finally, if it was 1/3 x squared, we would say it's been vertically compressed. It's been vertically compressed by a factor of 1/3. Okay, so I've got some homework questions here for you. Try to match graphs and things like that. This is a good exercise for you. So try those questions out, and I've included the answers from the back of the book as well. All right, good luck with that.